Today we're going to talk about something called BlackRay, and probably most of you have never heard about it, which these two guys should have, but besides them, it wouldn't surprise me if you've never heard about it. And it's a great honor for us to be able to speak here and present this to a lot of people that have great experience with databases and open source and community building, because we are at the very beginning of this exciting adventure. So, because we didn't want to get too technical, we're going to be talking a little bit about the history of this project, how did it even come about, a little bit about the technology. If there are actual technology questions, we have two developers here that can answer pretty much anything. I talk a little bit about how to position BlackRay versus the other excellent community projects that are out there. Because we are not out to dethrone anyone, we are actually out there to augment existing projects. Talk a little bit about the roadmap that we've charted up for the next year and a half. Maybe talk a little bit about the team behind this project at this point. It's still rather small. And then just wrap it up. It started with the history. Maybe a few words about what BlackRay really is. BlackRay is a relational in-memory database. We have SQL support. We have full text search in text fields, so tokenized searches. We have an object-oriented API. Although the entire index lives in RAM at all times, we persist it onto disk. It's very scalable and fault tolerant. That comes out of the history of this beast. It is open source, open community. Actually, it is dual licensed, GPL and proprietary. This again also comes out of the history of the project. We didn't start from ground zero with a new project. We actually started with an existing commercial project. The original ideas behind this go back rather long, in 1999. We developed a web phone directory for Deutsche Telekom. It was a pretty cool project. The only problem with the project was that Deutsche Telekom was not allowed to do it. It's the yellow page publishers that are allowed to put data on the web, not Deutsche Telekom. But basically back then we developed a predecessor of what we have today. The current code development started in 2005, pretty much as a data access library. It's been in production use at Deutsche Telekom since 2006. But we are not affiliated with that company, it's just happened to be one of our clients. It's been evolving from a library into more of an engine in 2007, 2008. And 2009, we decided to go open source with it. It was an easy decision for us to make, but a hard process to actually do. Cleaning it up, making it fit, getting the documentation ready, getting the possibility for other people to get involved. It was a rather long process for us.
What were your arguments to convince the others that you have to go open source?
Actually, it was pretty easy. Thomas and I, we decided we'd do it. And at that point, we were the only ones involved. So that was pretty easy, actually. I'm a big fan of open source. I've been contributing to lots of projects in the past 10 years and doing little patches, doing this and this. We use a lot of open source in the app. There was no question, basically, for us. The question is always, how does the business case tie in? But that's a totally different story. We're not going to talk about that today. So, why did we bother to build this? Are we crazy, or what's the problem? We started in 1999 and again in 2005, similar project, same set of constraints. It's a phone directory for Germany. There are 80 million people. Searches have to be fast, 10 to a maximum of 500 milliseconds. We're talking about 2,000 concurrent users in a call center, each hacking away one query every 12 seconds. That's a pretty high load for most databases. It's over 500 queries per second actually at the data engine level, because a query that the operator types may result in multiple queries on the engine. Data is updated once a day, but it has to be quick. The system should be offline for hours just because somebody's updating data. We need a tokenized index. such as the SQL contains function. We needed phonetic search and wildcard capabilities. People in the call center are lazy. They're not going to type a full name. They type 3 characters for the name, 3 characters for the city, 3 characters for the street, and they expect the system to come up with the right query result within milliseconds. So in 1999, when Deutsche Telekom came to us, we evaluated lots of things. Actually, it was pretty quick to find that it was not possible to build this with a traditional relational database. Oracle and DB2 had no text support back then. So you'd have to rebuild tokenized indices with other tables, which was not feasible from an update perspective. And MySQL couldn't really hold the amount of data that we needed. Tried it and it went bust and broke. This is 3.21 actually back then. So it's not as far advanced as it is today.
What size are you talking about?
For the full text index, it was about 500 million rows. And it just wouldn't work back then. It's not that we don't like MySQL, but we decided, and also our client decided that for the performance requirements they had, they wanted something to be in memory. So we built a little library in C. It was a pretty dirty hack, but it did the job. And in the end, it didn't go into production because they were not allowed to do it, which was not really something we thought of before. In 2005, same client, similar problem. They came back to us and they said, now build it again, but now not for the web, now for the call center. And again, this is a complicated client, lots of requirements, lots of consultants talking to them. And we evaluated quite a few options. Like that was Oracle, where we had worst case search performance, which would take minutes, and essentially lock the index for any other operation. The index, out of the 16 gigs of raw data, was slightly over 1 terabyte. So disk requirements, caching requirements, Oracle rack clusters, was not practical. We evaluated fast search and transfer. It's now acquired by Microsoft. The hardware requirements was huge. We needed 48 machines just to actually index the data. Fast is not transactional. So you load 8 billion documents into the index and you lose a few hundred or a few thousand. Now, of course, the documents you lose are paying customers. They may have bought yellow page advertisements. They're not so happy about them missing in the index. And there's really no good way of finding out what's missing. We experimented with a library called First by MC Object, which is now called ExtremeDB, which seemed like a very good fit, but it's written in Java. And ultimately, the garbage collection is what gets you when you have sustained search requirements, 24/7, no downtimes. And we looked at something called Thunderstone, but just looking at the price list, our client said, no way. We're not spending tens of millions in search appliances for this application. So in 2005, we went back to the drawing board and we decided that we again would build something, a lightweight data access engine, something very simple, something not very complicated. We didn't talk about SQL, we didn't talk about any advanced management features. We wanted to simply have a way of basically caching the data in RAM. RAM has gotten pretty cheap by 2005. These machines were easily available. So we started in C++. It was pretty clear that the business logic would be built in Java and possibly some parts in C++. So we decided on a network layer that would make it easy for us to attach Java clients and C++ clients to the installation. And the feature set was pretty narrow, pretty much geared to this one use case that we had. We wanted to make it fast, we wanted to make it easy to maintain, and that's really all that happened back then. So the current release we have, which is still based on that code, it's been evolving. It got some SQL, it got some better query API and advanced loader API, replication features, all these things that were built in when it evolved in 2007, 2008. And we now have release 0.90, which was released on June 12th. That's the date we went open source. The code itself is pretty good production level quality. At least we managed to sell it to people and they use it and they're happy with it. And they do have the source, so it's not that we're hiding something from them. And we've had very few problems with it. It's basically offers everything you need for large-scale search applications. It's not a typical just regular database. It's really geared towards high-performance search applications. And our SQL right now is a very, very, very small subset of what typically SQL makes up. Basically, we can do select, and I guess that's it. And the select has very few options. But this is something we're going to talk about when we look at the roadmap. Okay. Now let's talk a little bit about the technology and what's behind it. Why do we call it data engine? Well, it's not quite a search engine, and it's not quite a database. It's really a hybrid in between the two. It has a lot of things that you would find in a relational database, hierarchical model with instances, schema, and tables, join, that's all good. But from a search perspective, the wildcarding, the phonetic search, the token search, the full text capabilities, that's something really usually you find in search engines, and thus the name we call it data engine. So we support all kinds of combination of these things, even if they're very complicated. You can do full text queries, you can have extreme abbreviation and still do phonetic matching, which sounds a little bit odd because the more you abbreviate a word, the less it sounds like something else. But took us some time. It's just a requirement that a lot of people apparently have when searching, so we've made that work. Of course, you can define columns, which I guess in some other, like if you were using the scene, you'd have to define a document model for that. And it's relational with joins, so it allows you to model your data more like it comes in. People, addresses, cities, phone numbers, and they're relational. So updates of a city, for instance, will not force an update of the entire index. If you add a zip code in Munich, you just add one, you just update a little bit in the city table, not the rest of it. Little architecture diagram, and I have to say this is future technology. This is something work in progress. It's working in one of the developer branches, but it's not in the 0.90 release. Basically, we have on the very left-hand top side a management server. So on each node we have one management instance, which is a process that's used for connecting to the instance servers. It has an SNMP interface. All the command line tools work with the management server, and basically the singleton that allows you to manage the installation on that machine. In the very middle, for each instance, we have an instance server, which is responsible for each particular instance of the machine. The black thing is our data universe. Inside we keep the data in what we call a 5-perspective index. It has 5 layers, which we'll talk about a bit later. The data universe can be persisted into what we call a snapshot. Commands are stored in readme logs for transaction safety. And you can see C++ and Java APIs that connect to the instance server. And the little bit future technology we have in here is a new protocol. The SQL interface implements the Postgres protocol, so you can connect to the engine using Postgres clients. Again, we have no intention to reinvent the wheel, and we decided to implement the Postgres protocol rather than MySQL for licensing issues. We simply couldn't get to terms with Sun and the legal department about what it means to implement the MySQL network layer. Apparently there are different opinions within some, and we just don't want to end up in a big mess. So Postgres is a good choice. And of course it opens up, whether it's JDBC or ODBC or a PHP client or whatever you want. If it implements the Postgres network protocol, it should be able to connect to the engine. This does not mean that we are going to rebuild the entire Postgres SQL syntax. That's not even possible for us. We're a small team. But we have a useful subset of the SQL available for querying the data. If you have any questions, by the way, feel free to ask. You don't have to hold it until the very end.
Are you using JNI, the Java bindings, and just sitting on top of the SQL?
No. They are completely separate. This is using the ICE protocol, by0c, and so these are different versions using ICE. ICE actually turned out to be a very high performance choice in this case. We're not totally happy with it, also with the licensing about it, but it does its job and we're not going to kick it out just for that. Okay, so basically we have a hierarchical model. On each node that you install, you can have multiple instances. Each instance will run in a separate process. On top of these instance processes, we have one management process, again that's used for managing a larger installation. The system at Deutsche Telekom, for instance, has 6 engines located in 2 data centers, and the people are of course lazy, they just want to have one console and manage it. The instances are separate processes and thus completely separated from each other, which also means you cannot do a query that spans 2 instances. This is by design and not by some kind of thought. It was designed for the instances to be completely separated. Persistence and snapshots are taken on the instance level. So for each instance you can take separate snapshots, which we're going to talk about a little bit later as well. Inside an instance you can create a schema. Inside the schema you can create tables and then do what usually you can do. You can query. In queries of course span tables across different schemas. So once you have created an instance, once you have created a schema and you're ready to load some data, we have an XML description language for creating, for basically that holds the table and index definitions. At some point this will be moved into regular SQL syntax, but at this point it was easier for us to make it in XML, mostly because we have lots of index functions that I don't even know how we should augment the SQL syntax to implement those options. So we have probably a bit of a discussion on the mailing list about how to best do this. Data then can be loaded using CSV files, theoretically also XML files, but it's not very practical. So it's a standard loader utility. You just give it the XML description for the tables, which holds a column definition, and off you go. It will start bulk loading. Usually logging is disabled, so there will be no transactions during a bulk load. If it fails, you fall back to the last snapshot and redo the load. Command logging during a bulk update was just break the performance of the indexing. We attempt to index with the highest degree of parallelism we can do on the hardware. It's a little bit constrained by memory and of course CPUs, but it's done as much parallel as it can be done. We pretty much max out the CPU to 100% and that's it. Once all the data is indexed, you should take a snapshot, and then you basically have a persistent version of your data. The machine fails, it'll reboot and it'll reload the snapshot, and the data is alive again. We have, from this use case, some use cases we're not allowed to talk about, but this one we can, a little bit of performance data for the load process. Basically, there are 60 million subscribers in the current Well, apparently about 100 million phone numbers. And the raw data is approximately 16 gigs. Doesn't sound like a lot, but that's the amount of data they have. Once loaded and indexed, the index is 11 gigs in size. It contains all the raw data, so we don't throw away anything. We hold the result data as well as the index data in RAM. It takes about 40 minutes to index on a dual CPU machine. This includes all the reading of the file, all the indexing, all the creation of the data structures. And that's about 40 minutes dual Xeon machine. And the update performance, daily updates, about 300 megs, 200,000 records, about 5 minutes it takes to rebuild the index. And on a regular machine, no special disks or anything, loading the 11 gig snapshot takes 3.5 minutes. And that's the only time we actually access the disk. You could remove the disk after that, and we wouldn't ignore that. In actually most instances, the loading is done via the network. So you have one shared storage where the snapshots are stored. There's no need for indexing to take place on more than one machine. You update one machine, it writes the snapshot, all the other ones can read the snapshot, and that's how it works. Okay, let's talk a little bit about our data universe, and if you have specific questions about this, we'll have to address them to Thomas, because he's the guy.
I have a specific question about the previous slide.
Yes?
This is the German yellow page and white page data. Okay. In Italy, they are using MySQL cluster. Have you considered that instead of creating a new database?
Yes, of course.
Okay, and what was the main obstacle?
The main obstacle was, first of all, you have a client that has certain requirements. And the other thing is that we need to guarantee, and this is a written contract with a very high penalty, we need to guarantee that searches do not exceed 500 milliseconds.
Did you find with the cluster that that was not?
It's definitely not possible. You can ask Sun, will Sun guarantee this kind of performance, and they will simply say no. And if Sun
that doesn't. I mean, Sun doesn't guarantee a lot of things that are perfectly working. I mean, for a long time, MySQL didn't guarantee that a beta release was stable and wouldn't crash your system. That doesn't mean it crashed your system. I mean,
yes. However, we can very easily, using this data model, we can very easily define queries that will totally break that constraint.
I mean, did you like what were the queries that broke that?
Essentially, whenever you have a text index, full text index, and you have lots of wildcards, you have 5 search terms with wildcards, and they all match on the same column. And they lead to 0 or 1 result. This will always break that performance constraint. It's simply not possible. You have a certain number of IOs that you can do. And of course, you can start experimenting with all kinds of caches and do a little more of non-cached and this and this and this and this. But you also have to get somebody who says, okay, I accept that you will guarantee this, and I will actually operate this in a 24/7 environment for an operation that makes $500 million in revenues.
Okay.
That'll lose money once they start breaking the performance requirement.
So maybe I missed earlier because I wasn't right here earlier. I wasn't thinking earlier. But what about like Sphinx or a full text search? Did you look at those?
Sphinx really sucks at wildcards.
At what?
Wildcards.
At wildcards.
Yeah.
So the problem is really the wildcards.
Yes, exactly. Without wildcards, this is no problem. And once you start adding wildcards in phonetic, then it starts to get really bad.
Right. Most people don't use wildcards with full text search because the point is you have matches and sounds like in MySQL. So if you want,
yes, but
I'm just saying that's why. That's why they probably have not.
The call will simply not enter more than 3 characters.
Right.
They will be looking for Mrs. Leuthäuser-Schnarrenberger, and they will just type LEU.
No, that's fine. I was just wondering what the requirement was, and it was the wildcards.
Yeah, exactly. It's the combination. It's the wildcards and the combination of phonetics with wildcards that simply Maybe we're too stupid, but we just didn't manage to
MySQL
get it
cluster.
working.
No, I guess it's
Cluster
cheaper
doesn't have
to,
full text search. So yes.
right. Cluster doesn't have it, but full text search shouldn't be that slow. Like if you have all, if you can put your data in memory, you could use my ISOM and a full text search, and that would be in memory. And then, you don't
But
have to use
the
cluster.
size of that MySQL table is rather large.
Well, yes. I mean, I guess the point is that it's cheaper to build your own storage engine to hire people who aren't lazy and will type fast and move on.
A question about the indexes. Do they have to fit in RAM? Or
Yes, they have to fit in RAM.
so we are limited with the RAM, right? So we have to...
You're limited with the RAM, just like with Oracle, for instance, you're limited by the size of your network attached storage. Yes, it has to fit into RAM, but we make very, very cautious use of the RAM. Essentially, the reason we built these 5 layers is in order to achieve 2 things. We want to achieve maximum performance using the features we want, and we want to make the index as small as possible. Since we live in RAM, we don't have to work with something like B trees or tries or things like this. But we actually managed to work with lists, with sorted lists, and do binary searches, which is pretty quick using the sizes.
But there is no persistent search for indexes, right?
Yes,
Are they? Or
they are fully persistent.
on disk?
On disk, yes.
So if we don't have enough RAM, the system will still work, or does it? No, because it's allocating and reading from disk.
Exactly.
Okay.
It's persisted onto disk for persistence reasons, not for querying reasons. And I guess it could be changed, and we've had some discussions within the development team about this, and we look at whether it makes sense to actually put some of these layers onto disk, but we need to gather a lot more statistics from different use cases to see whether that makes sense. Essentially, our layer 1 and 2, one holds the dictionary, and one holds the postings. So out of these 2, we can basically deduplicate all the data. We only have the terms in here once, and from on here, we only work with relative pointers inside the dictionary. On top of the dictionary, we have a permuterm for wildcarding, actually dual permuterm for wildcard leading, trailing, and midspan. The third layer is what we call the row index, which tells us which term in what row relates to other search terms we need. Layer 4 is for multi-tokens, which is used for the full text search. And layer 5 is a very interesting feature. We actually have multiple values in one field. For instance, you can have historic data in one field. So it would be possible to have sort of like a table that has fields, and within one field you can actually have multiple values that we can also index and search without building the cross product of these values. And the statistics of the frequency of the terms and things like this are used for the query plan building. So the query plan does not rely on run stats or something like this. It really just relies on the number token counts out of these lists. Again, the expert is right here if you want to speak to him afterwards. Now we come to the snapshots again. So we have files. Each snapshot for one instance, for one version, is one file. And it will have the same size as you have in memory. And I guess it's possible to zip them or something, but we've never really bothered to do that. In our case, the 11 gigs is not a big file size today anymore. One snapshot always has all schemas, all tables, all data from one instance in it. And each snapshot has a version number. So if you do daily updates and you take daily snapshots, you build up a history of your data. You can either delete the old ones, or save them somewhere, or keep them online, and thereby have the ability to basically move back in time, like a time machine. How did my data look like yesterday? And Deutsche Telekom, they always had about 30 days of data online, in case they would ever mess up an update, which sometimes happened. they get the wrong file and they do an update, and all of a sudden they're missing important phone numbers or things like this. It was rather easy to say, okay, let's just revert to a snapshot from yesterday, and the world is good. So essentially, backup, restore, and the version control of the data comes at no extra cost. It just comes with copy and move. Again, we have transaction support in BlackRay. It's definitely not sophisticated like in most RDBMSs, but it's good enough for the use cases we have. All commands that modify data are logged into a redo log, so we have the ability to replay transactions in case we crash. We have a mutex on the index, so if update operations are performed, all searches on that part of the index will be suspended until the update is done. Actually, usually they will be aborted, because in a scenario where you have short response times, you don't want to select to block for 5 hours because somebody forgot to submit their return. But it's guaranteed that updates will not taint queries. Typically, the redo log is eliminated once you take a snapshot. Once a successful snapshot is taken, everything from the redo log is purged, and we have a new safe state for the system. Since it takes time to replay the redo log, it makes sense to periodically take snapshots and then live on that snapshot again. Although technically it would be possible to not take snapshots for many weeks, and then when the system crashes, just have it replay the redo log. It's not good practice. Now let's talk a little bit about the query APIs we have. As I mentioned earlier, they are built with ICE, the Internet Communication Engine by 0C. It's a network and object brokerage protocol, a very low latency. The protocol offers load balancing and failover, so you have multiple machines, and it will automatically select the machine with the lowest load for executing queries. Again, in the Deutsche Telekom case, we have 2 data centers, 3 search engines each. We have 8 call centers where the queries originate from. So the load balancing mechanism is simple, basically round robin, but for queries that all perform about the same performance, it's perfectly fine. We have Pythons for binding, bindings for Python. C#, Ruby, and PHP are in the works. It's not really complicated. ICE comes with something called Slice, which is an IDL compiler, and basically you can compile the stubs out of the Slice description of the objects. In our APIs, basically you build queries with an object builder. You can have any nested combination of OR and AND. You can have any combination of index functions such as phonetic, synonyms. So yeah, that's a synonym for synonym, I guess. Stop words. All the functions can be stacked. Token search and wildcards are also supported. They can also be stacked with the functions. Although at some point it's hard to verify whether a query still is reasonable. If you abbreviate too much and you have too much synonym and phonetic and wildcard and everything in it, at least for me, it becomes difficult to verify whether it still makes sense. Usage of the APIs versus SQL makes sense if you want to minimize overhead and have low latency, and if you have a special use case where you know in advance what kind of queries you will be executing. Also, high availability is very easily done using those query APIs. Let's talk some about the management features in BlackRay. As I said, on each server we have one management instance. That's a central broker. We have a set of command line tools for administration, taking snapshots, command line SQL, gathering statistics, viewing the logs. All this can be done with command line tools. And we have SNMP management, which was in a request by one of the clients. Instance health check can be done using SNMP, and you can gather statistics, including access statistics, performance measurements. All these things can be done via SNMP. So there's a standard MIP for it, just plug it into Nagios or whatever, and you get all the statistics out of the nodes. So what about administration? It's another big issue in most companies. Another database, a new system. What will the administrators have to learn? BlackRay, just like I guess most in-memory databases, require very little administration. There is one config file, for instance, which configures a few basic parameters, especially where you put the redo log and the snapshots. What network port you bind to, so the instance can be accessed. But it's not a whole lot of complicated things to configure. Disk layout, stuff like that, all of no importance. You just have to have enough space to store one snapshot. Otherwise, snapshotting will not be successful. Backups, recovery, just done by moving files. No complicated tools to use. It's not a whole lot of things you can do wrong. And basically, we know this from our clients, there is no daily administration required. There are no files that grow in size. Internal statistics are kept in memory as well. Well, I guess if you have lots of log files, at some point your disk will be full. But this is not something I would consider a special administrative task for this engine. Also, SNMP makes it very easy to do remote supervision of the engine. It's very easy to see whether it's hitting performance peaks or something like that. We've never had any issues with our clients regarding that. A little bit more details for the developers. The whole engine is written in C++, and it relies heavily on Boost. I guess to some developers it's a love and hate relationship. We've had severe issues with different versions of Boost, especially on different platforms. But we have a very stable set of third-party libraries at this point that compiles nicely with GCC and Sun Studio. In fact, one thing on our agenda is to actually do a performance comparison of GCC versus Sun Studio. Because there are some interesting articles regarding compiled code performance of Sun Studio 12, and we would like to verify that. Our engine is well behaved on Linux, of course, although originally it was developed on Solaris. It runs nicely on OpenSolaris and on macOS, and we've recently had a request to have it run on Windows. So far we haven't gone through with it because we don't actually have a Windows machine that we can develop on, but we may have to take that investment. Of course, which raises the question, what kind of Windows do we support? Do we support Windows 7 or Server or whatever? I don't know yet. The whole thing is a complete 64-bit engine, which it really would not make much sense to have a 32-bit, because then the amount of data you can hold is really too small. So it should be a 64-bit platform for it to be useful. And also we use CMake for multi-platform support. I guess CMake also sort of divides the developers, not everybody likes it. But I guess it's not possible to have one tool that makes everybody happy. Okay, let's talk a little bit about how we position BlackRay and other projects. Basically, we position it as something for query-intensive operations. It's in addition to existing databases, not a replacement for a database. So I'd actually like to move on and talk a little bit about some of the other projects.
Well, actually, since you're going to do that, I have a question. What happens if the data gets too large to fit in memory? Like, let's say I have 100 gigabytes of text data that I need to search.
Then we'll say...
What would you say would be the good solution for that with the same requirements?
Well, the good solution at this point, to be honest with you, we don't have it.
Okay. I mean, I don't think anybody has it.
Exactly. In our immediate plans, we will support partitioning and something like sharding. So you can basically divide your index on 2 machines.
Okay. Well, with partitioning, do you just mean sharding? Because partitioning, it doesn't really matter in memory, right?
Amongst the developers, we're not completely certain yet how to handle this. But it's a requirement we have also from other clients that say, okay, we need a growth path.
Right.
And the growth path should not be to buy a bigger machine with more memory.
Right.
So it's something, on the roadmap we have it, and
Okay.
it's something, again, it's not a lightweight choice what direction to go, and therefore it takes some more thinking and experimenting for us to really figure that out. So, what are the projects that we align ourselves with and we work with? Of course, we have MySQL, MariaDB, Drizzle, usual suspects, which are excellent databases, and also Deutsche Telekom. This is just used for the search. It's not used for the management of the data. So the day-to-day operation, where in the back office they change data, they don't change it in our database. They change it in actually an Oracle database, but could be any other relational database, and we just get propagated the updates. Postgres, of course, and there's lots of more embedded or non-embedded alternatives for RDBMSs. There are full-text search engines such as Sphinx or Lucene, and Sphinx is a very nice engine. It just has some issues with some of the features we needed, and therefore was not a good choice. We had a very nice chat with the Sphinx guys in San Jose at FrOSCon. And there are in-memory databases such as FastDB, H2, HSQL, which are of course written in Java, so they have a little bit problems with garbage collection. Also for us, in the beginning, it didn't seem like a problem with the garbage collection. It's only something you see in real life when it actually does not perform well. And when the engineers from Sun come to you and say, okay, you should go with some Java real-time edition. Basically do the memory management yourself, which sort of takes the fun out of Java and also makes it impossible to use something like HSQLDB. So although we love Java, for this it was not really a good choice. There are commercial alternatives, ×10, SolidDB, VaultDB, ExtremeDB, which again is written in Java, and dual license alternatives, CSQL. The sad thing is the open source version of CSQL really sucks. It has no persistence, and apparently it has some feature that makes it only 1/10 as fast as the closed source version. I don't know how to do that, but they basically say, well, you can evaluate the open source version, and if you like it, and it's too slow for you, then you can buy the other one. And of course, there would be MySQL with memcached, but again, it's for our requirement, then that was not the correct choice. Now, we do not aim at replacing any of these databases. We really aim at positioning ourselves in scenarios, in enterprises. We have search constraints, performance constraints that you cannot solve with the usual suspects, and that's where we would like to augment the scene. Is it the right thing for me? Well, it's, like I said, and I can't stress this enough, it's not designed as a RDBMS 100% replacement. Questions we always ask, do I need ad hoc data updates? Or am I happy if my data is updated in bulk? Once a day, once an hour, periodically, once a week. How important is full text search and wildcard use? How large is my data? Do I have gigabytes? Do I have terabytes? We had one guy in San Jose come to us and says he has 10 terabytes of raw data and a change rate of 10% of the data per day. Sorry, it's something, I don't know. Probably not a good fit. Do I need to be relational? Because if I don't have relational data and I don't want to be able to do joins, then Lucene is probably a really good choice. is SQL important for me? Do I want to have an application, but I would also want to be able to access the data using standard tools? These are the questions we always ask. So it will be a good fit for you if searches really outweigh updates. It is a good fit if data is updated in bulk. It needs to be available quickly. If you have gigs of data, and the 100 gigs would not yet pose a serious threat. If you need lots of select. If SQL is, at least to some degree, necessary. Who knows, maybe you just want to look in your index and see if the record is actually there. If relational data is required, and if source code must be available. It's maybe 5 years ago, in most enterprises, that was not a big issue. But the more company we talk to, the more of an issue this becomes. Lots of companies really want to build projects on open source. So at least you get a good feeling of if it would break, maybe you would be able to fix it. Let's talk a little bit about the roadmap. Pending immediate release is our admin console, which is called Remora. It's not as fast as we wanted it to be. It's built with Dojo, so that's why we haven't released it yet. We're still working a little bit on it. We have an upcoming release 0.10, which contains a full rewrite of the SQL parser, the Postgres client compatibility. So then we have JDBC and ODBC connectivity. The CLI tools are rewritten. Some bug fixes, including potential memory leaks that we've identified, and some basic authentication features for the instance level. The midterm roadmap, we will support data manipulation features such as ad hoc insert, update, delete. Right now this is not our strength. And we will support aggregate functions in select. So it will be more geared towards data warehousing, OLAP kind of applications. Scalability features, like I said, sharding and or partitioning. It's a little bit tricky, especially once you start talking about supporting join across partitions. With the sharding and or partitioning will come federated search. And we'll be working on the security features, which we have improved user access and access control concept and SSL for all connections. Right now, SSL is only available on the API. And a little bit improved statistics. The long-term roadmap, and this is something doesn't just depend on us, it also depends on how we work with other projects, will be integration with other DBMSs. For instance, 4 weeks ago we started talking with Monty Program about possibly making this a storage engine for MySQL. The problem is, this is not really a storage engine, this is a query engine. So it requires some modification of the storage engine interface, because a lot of the intelligence we have in our index, the statistics we need for query plan building, is not available via the storage engine interface, and therefore it's not, you can throw it away and just rely on the MySQL query plan, but that's not ideal for this scenario. So this would require some changes. Trigger-based updates, so that you can actually implement as a search cache for an existing database, which automatically updates the data. And we'll have some standalone engine improvements in the long term. More SQL and 2 compliance, possibly sub-select and union, and the support of triggers inside BlackRay, which probably will be needed for replication in a partitioned environment. Let's talk a little bit about the development team. The people in orange are the 3 guys that are here at the conference, so feel free to talk to any of us. We have inside software, so Andy and Frank, working on this, and one of our former employees, the other Andy we had, apparently currently is porting into AIX. Let's see how that goes. So about Thomas. Thomas is our director of development. He's the lead developer. Almost 10 years of development experience on his back, and he's been involved with it ever since. Currently involved building the network protocol stack, and he's basically our decision lead for new features. Our guy Mike, very senior software developer. I don't know exactly how many years experience you have, but it's a lot. Not over 10 years, yeah. And he was the first outside guy to contribute to BlackRay. Pretty big task because we had pretty much zero documentation and not so ideally structured source code. But he's living proof that it can be done. And we are very happy to have him here at the OpenSQL. Okay, a little bit about me. I've been in commercial software development for a little bit over 10 years. And been involved in building the first one, 1990. And basically I'm considered project sponsor because I am not actually involved in day-to-day development, but I'm sort of involved in making design choices with Thomas and Mike, and I see myself more as a guide and a coach in the process. Although I do like to program, so who knows? Who knows whether I will be able to get the biggest dirty. Okay, what to do next? I would recommend you get it, you try it out. You can register yourself on our Forge, which is built with Redmine. There we have the ticketing system, everything. If you're not registered, you can see everything. You just can't add tickets or comment tickets. SVN checkout of the sources available. Currently we're using Subversion, which may at some point change. I would like, of course, people to get involved. Try it out, see whether you like it. Give us some feedback if you don't like it. If you like it, even better. Give us some positive feedback as well. If you see something you don't like, maybe create a ticket so somebody can actually fix it. We have an active mailing list. It's recently been created, which should be used for discussions and encouragement. Of course, we would like people to contribute. In this case, we will require something like the Sun Computer agreement because of it's a good policy not to just accept contributions before agreeing on how we're going to handle licensing issues. Okay, this is how you can get in touch with us. We're also on Facebook, by the way. For all of those of you who are we tweet every now and then, although it's been sort of quiet. And downloads of the binaries and the source code is available on source code as well. So if you want Subversion access, go to our SVN repository. But if you want a particular version with binaries available, source code is the place to go. If you have any direct comments or anything, don't be afraid to shoot an email to me or Thomas. Yes?
The contributor license agreement, who owns the copyright? So you sign it, and who do you sign over the...
We do it the same way MySQL does it. The reason being, we have a dual license requirement, which is something we can't get out of right now, and therefore it's handled just like MySQL. But our take is...
Signed in general.
Yeah. Our take is that is pretty acceptable within the community.
Right. Yeah, because the CLA is for two purposes. One is legal cover and one is sort of the social cover that you're ensuring that people have the right to give you code.
Yes. It's a very complicated matter. It's a very nice O'Reilly book out on open source intellectual property. Very interesting reading. So we would like to do it correctly. Okay, that's it from me. We have a few more minutes for questions if you have anything.
do you plan to implement the storage engine for MySQL? Or that's the same problem, right?
Exactly. Right now, it's the same problem. If we find an intelligent solution to this problem, and I'm welcoming any suggestions people may have.
What about making a patch for the API that is not present in the current plugin API?
I'm sorry, making a patch for the storage engine?
You said that the problem that we have now, you cannot make a storage engine for MySQL because the plugin API is not complete.
Yes.
Why is good for MariaDB and it's not good for MySQL?
No. MariaDB and MySQL have the same problem.
Yes. So
We have.
what is the difference? Why did
I
you
guess
say
the question is
MariaDB
why
there?
are you talking to Monty and putting it in MySQL in MariaDB instead of, or in addition to, have you talked to MySQL about putting it into, and I'm guessing since you said it works.
You know, MariaDB is just MySQL 5.1 with a different set of bugs.
Exactly.
Right.
Yeah.
So the question is, are you, okay, here's how a better question. Are you planning on contacting MySQL to put this, to be able to do the same
Of course,
thing?
we are
Okay.
friends with Lens, and of course we will
Right.
contact MySQL about this. You did already. Yes.
Oh, okay.
We have.
Was that basically
the
the
problem we
question?
have is we have limited bandwidth. It's a small company. We have 5 people, and we also sometimes have to make money.
Right.
As much fun as it is to program, sometimes we also have to do work that's paid,
Right.
and therefore we have limited bandwidth. But it's not that we say we only want to work with MariaDB and we don't like MySQL.
But that's what it sounded like since you said we
No.
worked with MariaDB. That's why
No,
it's
it's just
confusing.
we've had, because of good luck, had good interactions with the guys from MariaDB. But it's not that we don't like MySQL.
You just haven't had good interactions with them.
We just haven't had the time to
Ah,
talk
okay.
as much in detail. And again, the changes that are required for MariaDB will probably be the same changes that are required for MySQL.
Okay.
And just have to start somewhere. And
So it's just
Again,
weird
it's
when you
again,
say
it's-
the reason is because because we have had good interactions with MariaDB, then it sounds like the reason is because you haven't had good interactions with, you know what I mean? That's why I'm asking, because I'm confused. That's all.
yes, it's sort of like that.
It's just you happened to talk to Monty before you talked to, that's all.
Exactly. Yes. Yeah. We ran into them before we ran into the other guys.
That's all.
And
Now I'm not confused.
it's not something we'll be undertaking in the next 4 weeks. It's something we have to be realistic about our time. We have pretty booked until the end of the year, so this is something at the beginning of October, where hopefully we'll find the time to actually sit down for a few days, maybe a few weeks, and nail it down. Because getting into a LAMP sort of environment would be a very good choice for us, something we are really looking forward to.
Have you made contact with any Linux distributor yet about including
Yes. OpenSQLCamp and Ubuntu. And yesterday we spoke with Fedora. And one of the reasons we come to these conferences is, of course, to get more in touch with the people. It's something about the social component of knowing each other that makes a big difference. And actually we've had very good feedback from the guys with at Ubuntu and OpenSQL. Okay, thank you very much. Thanks.